Yeah. So hi everyone. So today we are going to learn about a very simple, very easy, very common question called finding the nth element of the Fibonacci series, right? So so yeah, so what we have been told to do, we have to find the nth element in the Fibonacci series. So this is a so, so the main objective of this video is to learn about the concept of recursion. So we are just using this as an example, using this question as an example. So yeah, so I'll be explaining about recursion and yeah, so let's get started. So basically, what is a Fibonacci series? So we start out with 0, comma 1, right? So now the next element is the addition of the last two elements. So 1. So next the element will be 1 plus 1, which is 2. Next it will be 2 plus 1, 3. Next it will be 5. Next it will be 8. And next like 11 and it go on. So you get the point, right? So the n. So if you want to find the nth element, you need to. It is the addition of the n minus 1th and the n minus 2th element. So, for example, if we are told to find the sixth element of the Fibonacci series, give me the sixth element. So we need to return first, second, third, fourth, fifth, and sixth. So we need to return 5 as the answer. We need to return 5 as the output. So now what will so this is the what we have to do. So basically how we solve this problem, we if we want to find the nth element Fibonacci number, we just need to find the sum of the n minus 1th and the n minus 2th element, last and the second last element. So just keep that in mind. So yeah, so now we are going to solve this problem recursively. So how are we going to do it using recursion is, so let me write down the code, it will be easier. So int fib of n, right? So this is the function header. So I'll just do the return. So if this is the break, it has to break out at this the breakpoint. So if n is equal to 1, right? So we return 0. Now if n is equal to 2, right? So if n is equal to 1, give me the first element. So if n is 1, it means give me the first element of the Fibonacci series, right? So what is the first element? It is 0. So we just need to return 0. Now, if somebody asks, give me the second element of the Fibonacci series, what will you return? So the second element is 1. So we just return 1, right? So now find the nth element, same thing what I said. So int last is equal to fib of n minus 1, right? Now int s last is equal to the the n minus 1, so that is the last and the second last element. So next this is fib of n minus 2, so this is the last and this is the second last. I'm calling it s last. So now int sum is equal to last plus s last. Then we return that sum. Now, I'll be going through each and every line of code, what exactly is happening here. But yeah, so just one important thing to keep in mind is when the control is at this point, right? So now we see that a recursive call is happening. See, we are calling the same function but with a different number. So the point you have to remember is each time this Fibonacci, so when the control is here, all these recursive calls have to fully complete. Only after they are fully complete, right? Only once they are fully complete, the control will come to the next line. Until then, the control will be here only. So even though the recursive calls are happening, they're happening and they're taking place, the control will be over here, and only after once it fully completes this executing this recursive Fibonacci call lines, only after fully only after it fully completes executing this line, it comes to the next line. So now over here also again the same thing is happening, right? So it's calling the again recursively, it's happening. So only after this fully all the recursive calls gets fully completed, it will come to the next line and then it will continue executing. So this point please keep it in mind. So I'll show you how it is. So now let's start. So let's take an example. So it's very important to remember this one, so please remember it. So now take one example, sixth element, right? So now give me the six. So now n is six, right? So now what will happen when n is six? So now n is one, so six is not one. This if condition won't satisfy. Six is not two. This if condition won't satisfy. Now int last is equal to fib of n minus one. So now what will happen? Int fib of n is 6 now. Now we are calling int fib of 5, right? So now when fib of 5 is getting called, what will happen? Again, same thing. If condition it will check, it won't satisfy, it won't satisfy 5 is 2, it won't satisfy because n is not 2, n is 5. So now what will happen? Int last is equal to fib of 5 minus 1, which is fib of 4. So now fib of 4 will execute. So now fib of 4 will start executing. Int fib of 4. Now fib of 4 again, these two conditions won't satisfy. Now int last is equal to fib of 4 minus 1, which is 3. Now fib of 3. Now int fib of 3. So now what will happen here? So fib of 3, and this 3 is not 1, 3 is not 2. So these conditions won't satisfy. Now int last is equal to fib of 3 minus 1, which is 2. Now fib of 2 will get called, right? So now when fib of 2 is getting called, so fib of 2, so int fib of 2 is getting called here, right? So now fib of 2, it will start executing. So now n is equal to 1. 2 is 1? No, 2 is not 1. So now n is 2, it will return 1. So here the if condition is satisfied, right? So if condition is satisfied, so now it will return. So now here the if condition is satisfied when n is 2. So as soon as 2 is equal to 2, yes, it is true. So it will return 1. So now it will return 1, right? So it will come back. So now where it will return 1? So it's getting called here, right? So here it will return 1. So 1 is getting returned here. So last will be 1. Now what I was told, right, this important point. So now the next line will execute. See, so now this one's fully completed, right? So it returned. So now the next line will execute int s last. So now int s last is equal to fib of n minus 2. So fib of n minus 2 is what? 1, right? So now fib int fib of 1. So now here again, if it's in the first line itself, 1 is equal to 1, so it's got satisfied. So now it will return 0, right? So it returns 0. So here 0 will come. Where it will return 0? Here it's getting called, right? So here it will return 0. Now int sum is equal to what? Last and s last. So 1 plus 0, which is now 1. Next line will execute. So it found the sum as 1. So now sum is 1. Now what will happen? It will return the sum. It will return, just return 1. So what will happen here? 1 will get returned here, right? So where it will return 1? Fib of 3 is getting called here. So it will return 1 here. So here 1 will come. So fib of 3. So 1 fib of 3 we calculated as 1. So here 1 will come. Now int s last will start executing. Int s last is what? So fib of n minus 2. So 4 minus 2, which is 2. Now again fib of 2 will execute. Again fib of 2 will get called. So again fib of 2 is getting called. So already we had called once before. Now again it is getting called. The same thing we are getting called. So this is also an important point. So keep this in your mind. We are calling the again. So fib of 2. Now what is fib of 2? We already know what is fib of 2. It will return 1. So we can just directly add 1 here. Right. So now int sum is equal to last and s last. So 1 plus 1 is what? 2, right? So now we just return 2. After this, what we do? So now where it is returning to this one. See, before we are returning 2. So we are 2 here. So now what is happening? The next line will execute. So int s last is equal to fib of n minus 2. So what is fib of n minus 2? 5, 4, 3. So fib of 3 will execute. Now again fib of 3 will execute. Fib of 3 will again call fib of 2 and fib of 1. Then again fib of 2, fib of 1. So again the same repeated calls will happen, right? So in the end, what will fib of 3 return? It will return me 1. It will return me a 1. So fib of 3 is 1. So now we can calculate sum. So int sum is equal to last and s last, so which is 3. So now we return 3, right? So now here to where we return 3, this is the function call it happened, right? So here we return 3. Now this has fully finished executing. It has fully finished executing, and finally last has been assigned the number 3. Now this line has completed executing. Last has been assigned number 3. Now s last, now as this control will come to this line and s last will execute. So int s last is equal to, now what again it will do now? So here n is 6, right? So now it will call int fib of int fib of n is 6 now. So n minus 2, which is 4. Fib of 4 will get called, right? So again, none of the if conditions will get satisfied. And then int last is equal to fib of 3, right? So same thing, see, the same thing, whatever I put before. Now fib of 3 will start this one. Again, the same thing will happen, right? So all the function calls will happen. And then in the end, what did fib of 4 return? Fib of 4 return 2. So in the end, I'm not going to write everything. The same thing again happens again. All the function calls happens again. So fib of, so what will it return? So fib of 4, it will return, what will fib of 4 return? It will return me a 2. So we already calculated that. I'm just putting it back, right? So here it will return me a 2. So once it has returned 2 over here, so 3 plus 2. So 3 plus 2 is what? So now this has full, it has returned 2 here. So now 2 is done. So s last gets assigned the value 2. So now this line is fully complete. It's fully complete. Now execute will come here, right? So sum is equal to last plus s last, right? So 3 plus 2, 3 plus 2 is what? 5. So now sum is 5. So now sum will get returned. So we are returning, in the end we are returning 5. So what the answer we wanted 5. So yeah, so basically this is how the recursive calls happen, right? So I just wanted to visualize how the recursive calls will happen. So that's why I have explained this one. So in the end, we return 5, and yes, 5 is what we wanted, and we are taking that as 5. So, so this is the one way to solve it recursively. So let's look at the recursive call stack. Let's look at the call stack. So so what will happen? So what's happening here? So first fib of 6 we called, right? So now fib of 6 is now calling. What is fib of 6 calling? It's calling fib of 5, right? So now what is fib of 5 doing? It is calling fib of 5. So fib of 6, so let me explain this from the start. Fib of 6 we started. Fib of 6 we started, it called fib of 5. So that's why I wrote fib of 5 here. Right? Now fib of 5 will now what it will call? It's calling fib of 4. Right. So now fib of 4 is what it is doing. It is calling fib of 3. Now fib of 3 what it is doing? It is calling fib of 2. So it is calling fib of 2. Yep. So now it is calling uh, fib of 2. right? It's calling fib of 2. See, 3 is now calling fib of 2. Now, here, fib of 2, when fib of 2 is called, what happened? It returned 1, right? So, it returned a 1. So, it returned 1, right? So, RW2. Okay. So, here it returned fib of 2. What did it return actually? It returned 1. Fib of 2 returned 1 over here. See, fib of 2 it returned 1. So fib of 2 will return 1. So it returned 1, right? So next thing, after fib of 3 has, so fib of 3 has two recursive calls here, right? So as you can see, fib of 3 has two recursive calls here. So fib of 3, yes, two recursive calls. So one is fib of 2 returned 1, right? Now it has one more recursive call, that is fib of 1. So fib of 1. So what will fib of 1? So fib of 1, what did it do? It returned 0, right? So it returned a 0, 0. So now what did fib of 3 do? It added both of them, sum, and then it returned sum. It returned the sum as 1. So it returned 1, right? So now now fib of 4, so now it returned fib, so fib of 3 it returned 1 to 4. Now fib of 4 has two functional calls, right? So one is this fib of 3 what we saw, so it returned 1. Now again it has one more functional call. So what is that? So it is fib of 2. So fib of 2, now what is happening? Fib of 2, it is now calling, it is returning 1, right? So here it will directly return 1. So now fib of 4 what is doing? It is adding both of them. It is adding 1 and 1, which is now 2. So fib of 4 what it is doing? It is now returning 2. So now what is fib of 5 doing? Fib of 5 is basically doing two things. Fib of 4 we have already calculated what it will return. It will return 2. Now it is doing one more functional call. It is doing one more functional call. So it is fib of 3, right? So fib of 3 is here. So now fib of 3 what it is doing? Fib of 3 it is again calling fib of 2, right? It is calling fib of 2. Fib of 2 what it is doing? It is returning 1, right? So now fib of 3 is again doing one more functional call. It is doing fib of fib of 1. So now what is fib of 1 doing? It is returning a 0, right? It's returning a 0. So now fib of 3 what it is doing? It is taking both of them and adding. What it is doing? It is adding both of them, 1 plus 0, and here it is returning 1. It is returning 1 over here. It's returned 1, returning 1. So now so fib of 3 it is returning 1. So that's why we got 1 over here, right? So fib of 3 in the end, whatever, whenever, wherever it will call, fib of 3 will always return 1. So 1. So we got 1 over here. So basically fib of 5 was doing two things. It was calling fib of 4 and fib of 3. Fib of 4 returned 2. Fib of 3 returned a 1, right? So now next thing, what will happen? Fib of 5 will add both of them. It will add both of them. It will return 3. It will return a 3, right? So now after returning a 3, fib of fib of 6 will get 3. See here we have 3 here, right? So now fib of 6, what it will do? It will call fib of n minus 2. So it will call fib of n minus 2. What is fib of n minus 2? It will call fib of 4. Now what will fib of 4 do? Fib of 4 is now calling again fib of 3. Now fib of 3, what it is doing? Fib of 3 is now again calling fib of 2. Now fib of 2, what it is doing? Fib of 2 is now again returning a 1. It is returning 1, right? So again fib of 3, what it is doing? It is now again calling fib of 1, right? So fib of 1. So now what it is doing? Fib of 1, it is returning a, so fib of 1, it is returning a 0, right? So fib of 1 is nothing but 0. Okay, fib of 1, what it is doing? It is returning 0. Now fib of 3, we are still in fib of 3 only. What is they doing? Fib of, we are doing 1 plus 0, it's returning 1. So this 1, it will return 1, right? So now fib of 4, now we are, it will return 1 to fib of 4. See, fib of 4 got a 1, fib of 3 return 1 to fib of 4, and fib of, so now last, so 1 got assigned to last of fib of 4. So now fib of 4, what it will do? It will call fib of 2, right? It will call fib of 2, fib of 2, it will return 1, so it will to this return the 1 over here, right? So now after this, fib of 4, what did it do? It added both of them again, right? 1 plus 1. So now it returned a 2, it returned 2 over here, right? So once it returned, what did it return? It returned a 2. So now it returned 2 here. See, we got a 2. So initial, so this one we call fib of 4, all these operations and did it, and then it returned a 2. So now what happened? It will add both of them. Sum is equal to last plus s last. So what is last plus s last? 3 and 2. So this is 3 and 2. It will return 5. So the sum is equal to 5, and then it will, so 5, in the end we got 5. So that's what we wanted, and then we are returning 5. So yeah, so for n is equal to 6, so for n is equal to 6, we are returning the fifth element. We are returning the fifth element, right? So now, since we are returning the fifth, n is equal to the sixth element, we want the sixth element, we just return 5. So that, so this is how recursion works, and this is how we have to visualize recursion. This is very important. This is what they call the recursion tree. So many people, that's how they visualize recursion, right? So we need to remember this, how we got this one, how we can arrive at this one, how we can draw this one. So this is what is very important. Now now coming to the time complexity of this one. So as you can see, for each n, we two calls are happening. See, for each n, two calls are happening. Each n, two calls. So for each of the n, two calls are happening. So what is the time complexity of this one? So two calls are happening per n. So it is 2 power n. So the time complexity is 2 power n, right? And the space complexity is O of n. So why? Because there will be, in the end, there will always be n stacks available. So the highest number of stacks available inside this function call stack is n. So this is the space complexity. So this is the time and this is the space complexity. So as you can see, it is a bit high, right? So time complexity is a bit high. So now how do we make this more efficient, right? So as you can see, though we have made a function, so though we over here we already found out what fib of 4 returns, right? See over here when we were doing the very first step, we already got to know what fib of 4 return. So it's returning back 2, right? But then again over here when we were calculating fib of 4, we again had to do all this one. Is all of this necessary? Is all of this necessary? No, right? We don't have to do it twice. See, once we already calculated fib of 4 is 2, we need to make use of that one. So we shouldn't be calculating all of them again. So you get the point, right? So already we calculated once fib of 4, already we calculated once fib of 3. See, again we are calculating again fib of 3 also. So so we should make use of what we have already done before, right? So so this is where we can make this algorithm more efficient, right? So how to make this algorithm more efficient? By using the already calculated values, by using the already calculated values by using already calculated values, right? So this is how we can make it more efficient. So over here now this new thing called, so how we are going to do this? We are going to use this technique called memoization. We are going to use this technique called memoization. So so how it works? So basically, this is how it works. By using the already calculated values, we don't have to calculate it again. So let me tell you how it works first. So basically, what happens is, so we are doing, so whenever we calculate something, right, we will have a map. So basically, first thing we'll have a map. So in that map, we know that okay, if I ask for the first element, return 0. If I ask for the second element, we return 1. So just like how I had written like hard coded, right? So 0, 1. So like that only we'll create one map also like that one. Okay, so when they have asked 1, you just return a 0, right? And when they have asked for the first element, you just return 0, right? And when they ask for the second element, we just return 1. So we'll hard code this into our map initially. It's hard coded into our map. So this is the starting element, right? This is the base. So this is where we have to start. So initially we'll have both of them here. Now, now we'll calculate 3, 4, 5, 6, and all, right? So once we calculate each time, so for example, if we calculate what is for 3, we will add that number here. Next, we'll calculate what is for 4, we'll add that number over here. What is the fourth Fibonacci element? We'll add that number over here. What is the fifth Fibonacci element? We'll add that number over here. So now afterwards, after we know everything, now again we have to make a call. Again, we have to find out what is 3, 4, 5, and others, right? So we won't be making this call, we'll be making use of this map to get back that number. So simple. So this technique is called what they call memoization. We are going to create this map, and then I hope you get the point. So this is how we are going to do it. So let me write down the code for this one first, right? So now basically the function header will be something like this: int fib of map comma n, right? So now if map dot contains key, so if map dot contains key n, we can immediately return it off. So if map contains key, return map dot get of n. So it returns the value. So now, so initially what I said, we'll be having get me the zeroth, okay, sorry, get me the first element. What I have to do, I have to return 0. Get me the second element, I have to return 1, right? So this is the base condition. So whenever we find, okay, we already key is there, we just return it, right? So if the key is not there, right, the key is not there, we need to do int, the key is not there, we need to do int last is equal to fib of map of n minus 1, right? So after this, int s last is equal to fib of map of n minus 2, same thing, right? So now int sum is equal to last plus s last, right? So now when as soon as you calculate the sum, it is important that we have to update the map, right? So map dot put, right? So for n, this is the return type. This is the sum for the nth element. This is the sum what we calculated, right? So we return sum. So now let's do a dry run for this code. So the same thing will take, right? So 0, 1, 1, plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8. So now return me the sixth element. I want the sixth element. So what I should return for this one? I should be returning a 1, 2, 3, 4, 5, 6. I should be returning 5, same as before. So now let's see if this works. So now initially map will contain 1 and 0, right? So now I will, what I'm pushing here, I am putting 6 here. Now 6. So now what it is happening, if 6 is not in this key is not contained in the map. So now I will put, I am calling int fib of map. I'm calling 6 minus 1, which is 5. So now 5 I'm again calling here, right? So map of 5. So now again it doesn't contain the key, right? So it doesn't contain the key. So it will call int last is equal to fib of map of 4, right? So now what will happen? It is calling int fib of map of 4. So now again calling int last is equal to fib of map of 3, right? So n minus 1 calling 3. Now let me just move this aside. Okay, not able to. Okay, so now map of fib of 3. So so now what is happening? Now what is happening here? So now again it is calling int fib of map of so 4. So it's called n minus 1, which is 3. It will call fib of map of 3. So now int last is equal to fib of map of 2 to call fib of map of 2. So now when fib of map of 2 is getting called, what will happen? So int fib of map of 2, right? So int last is equal to, what is this? So map of 2 it will call, right? So now again it will it will come here, right? So map contains the key. Yes, it does contains the 2 contains 1. So it will return. So it will, sorry, it will not come here. So map of 2 we call, right? So it will check for 2. Yes, it contains the key. 2 is there in the map. So it will return 1. So it just returns 1 here, right? So 1 it will come here. Now the next line will execute int s last is equal to fib of map of n minus 2. What is n minus 2? 1. 3 minus 2 is 1. So 1 will come here. So it will call fib of map of 1. So it's calling, I'll just write it down here. Int fib of map of 1. Right? So if fib of map of 1 is getting called, so what will happen? So it will again come here map of 1, map comma 1. So it contains, map contains key. Yes, 1 is here, 1 is here. So it will return 0. It will just return the value. So it will return 0. So this one, what will happen here? It will return 0, right? So now it will return 0. So now sum, what is sum? So sum is equal to last plus s last, 1 plus 0, which is now 1, right? So now map dot put of n, what is n here? 3, right? So n is 3. So now put of 3 comma sum, what we calculated sum as 1. So we put 1 here, right? And then what we do, we return that sum. We return that sum to where? Here it is getting called map of 3. So we return, what is the sum? 1. So sum comes here, right? Now what will happen? The next line will execute int s last is equal to fib of map of n minus 2, fib of map of 2. Now fib of map of 2, what will happen? It will call, fib of map of 2, right? So it will call this one only again. So it will call this one again. Now fib of map of 2 again, it will call 2. Yes, 2 is contained here. So 2 keys contained here. 2 is in the the map contains the key which is 2, and it get it. So it returns 1. So it returns 1 over here, right? So now once it returns 1, so it will immediately return 1 back to me, right? So here also map of 2 we call it, it returned 1 back to me. So now int sum is equal to last and s last. So sum is 2. Now what is will happen, what we have to do? So now map dot put of n, what is n? N is now 4 and sum is 2. Now it will put 4 comma 2 over here, 4 comma 2, right? So next it will return the sum, return 2. Now where it will return, see it's getting called over here, return 2. Now int s last, next line will execute int s last is equal to fib of n minus 2, which is 3, fib of map of 3. So now fib of map of 3 will get called. So fib of map of 3 will get called. So now if map contains key, is 3 contained here? Yes, 3 is here, 3 is here, right? So if map, so immediately we return 1, we return 1 here, 1 comes here. Now what we do? int sum is equal to, so we return back. So this won't execute further. In the if condition only we return back. So int sum is equal to 2 plus 1, which is 3. So now we put map dot put of 5, n is 5 and the sum is 3. We put 5 comma 3, right? So now 5 comma 3, we put it in the map. So now so we put 5 comma 3 in the map, right? We put this, then on the next line will execute. What is the next line? Return 3, return the sum. To where it will return? It will return where this is getting called, it will return 3. Now the next line will execute, right? Now that this line will execute. So what it is doing? This is again calling fib of map of n minus 2. What is n minus 2? Fib of map of 4, right? So fib of map of 4, if next line it will execute this line if map contains 4. Map contains 4. Yes, it contains 4. So we return value 2. So we return immediately. We don't do any of these executions, whereas previously we had to do all these executions, right? So 2 times we have to do 4 again, 2, okay, calculate 3, 2 and all. So we don't need to do all of that here, right? So immediately if map contains the key, which is 4, immediately we are returning back. We are returning back 2. So we're returning back to over here. So now what it will do? So now it will do last and as last. So 3 plus 2 is 5. So now again it will add, right? So now again, so now what it will do? It will add 6, comma. Now what is the sum? So it will add. So now, okay, it will return 2 over here. So now the next step, what it will do? It will do sum of last and as last. It will return, it will be 5. So now what it will do? It will do put of n, right? So n is what? 6, 6, and the sum is what? 5, right? So it will put this in the map and it will return 5. So return the sum, so it will return 5. So 5. So in the end, we are returning 5. So now what do we wanted initially? So our task was to calculate the sixth element. So we got the sixth element as 5 and we are returning, see, we are returning 5 here and 5 is the right answer. So this is how we put everything. So in the end, we have the key value pointing to the last element what we did also. So give me the sixth element. Give me the sixth element. What it will return? It will give me 5. So this is the code. So let's let's implement this code. So just so that it will be clear. So what is the space? Before that, what is the time space complexity? So the time complexity is basically n itself, right? So it is n only because we are not making two calls. We are not happening. I mean, the call is happening, but it's not. We are immediately getting it back because of the map. So it will be n, and space complexity will also be n because any point of time n stack spaces will be there. So now let's look at this tree. Shall we look at this tree? So now what will happen? So fib of, I'll just ignore this map file. So fib of 6, right? So fib of 6 we call, uh, there's no space here. Okay. So now what exactly happened? So fib of 6 first we called, right? So fib of 6 we called, right? Fib of 6 we called. Next, what will happen? Fib of 5 we called. Fib of 5 we called. Next what happened after calling fib of 5? Next we called fib of 4. Right? So next we called fib of 4. Now after doing fib of 4, what will happen? We are calling fib of 3. Right? Fib of 3 we called. Fib of 3 we called. Next, after doing fib of 3, what will happen? We call fib of 2. Right? So we call fib of 2. After calling fib of 2, what happened? After calling fib of 2, fib of 2. So when we call fib of 2, we are returning 1. So we returned 1 over here, we returned 1 over here, right? So next fib of 3. So we are still in fib of 3 only. So we are still in fib of 3. So next it will call fib of 1, right? So it is calling fib of 1, calling fib of 1. So when it calls fib of 1, what it is doing? Fib of 1, what it is doing? Tell me. So it is doing returning a 0, right? So we need to return a 0 over here. So returning a 0. Now what is fib of 3 doing? It is adding both of them and it is returning a sum. So it is returning a sum of 1, right? So it is returning a sum of 1. Now what is fib of 4 doing? Fib of 4. Fib of 4, what it is doing? It is returning. So now it is going to call fib of 4. So now it is called fib of 2 as well. So it will call position this. So now fib of 4 is here. Now fib of which one it is calling? It is calling after doing fib of 3, it is calling fib of 2, right? So when it is calling fib of 2, when it calls fib of 2, now it's already there in the map, right? So it will immediately return off 1. So it will immediately return 1 over here, right? So now, now what is fib of 4 is doing with these two numbers? So it is adding both of them. It is adding both of them and it is returning 2. It's returning 2 here, right? So now fib of 5. Fib of 5, what it is doing? It is calling fib of 4 and next it is calling fib of 3. So since it is calling fib of 3, so what will happen here? So fib of 3, it's immediately returning 1 here, right? It's immediately returning 1. It's not calculating further, right? So 2 plus 1, 3, it added and put it returned 2 plus 1, 3. So so fib of 5 added 2 plus 1, 3 and it is returning 3. Next 3 it has returned. So next fib of 3 comes here now. Fib of 6. So once it has called fib of 5 and next other time it will call fib of 4. Now fib of 4 again immediately I am returning. It is returning a 2. It doesn't need to see, it's not calculating further as you can observe. So it immediately it returned back. So but before it had to calculate all of this. See, for it had to calculate do all this, calculate all of this. See, but here I am immediately returning it back, right? So fib of 4 immediately returning back 2. So now what is fib of 6 doing with these two numbers? It is adding both of them. 3 and 2 give me back 5. It gives back 5. So 3 and 2, 5. And then the end fib of 6 will return back 5. So 5 is what we wanted and 5 is the answer we are getting. So this is the tree stack for this one and this is the tree stack for the tree for this one. So as you can see, this is more efficient, right? So we are adding we have memorized the values and we are making use of it. So much less functional calls are happening here, right? So this is a more efficient approach. So and time complexity and then space complexity. So two times you're not doing, we're just making it once. So yeah, so this is the space and time complexity. Now, whatever code we have written over here, right? This using memoization. So let's execute it once. Let's execute it once here, right? So now I'll just create one map. I so map just integer map equals to new hash map class. So now, like I had told in the beginning, I have to put these both values first, right? So give me the first element. So you can immediately return map dot put. If I give me the first element, return 0, right? So now map dot put give me the second element, we return 1, right? So this is the initial map thing. So now we call int result is equal to map of. So I'll just create one fib that will create a map. It will take a map and it will take n, right? So here I will define int n is equal to give me that sixth element. So now when I call this one, it should return me. So n is equal to 6. Next I'll just output this result. So whenever I call with n is 6 here, so I should get result is equal to 5, right? So that's what we got over here also. We return 5. So now let's define this function. So fib is okay, it's importing something else. I just put a double B over here, right? Yeah. So now we have the function. So now basically what we do here. So it has a map and an n. So now if map dot contains key and if it contains n, just return immediately. Don't do any further steps. Return map dot get of n. So int last is equal to, just remove this bracket. Next int last is equal to fib of map of n minus 1, right? So next map of n minus 2. Next int sum is equal to last of s slash. So now map dot put so sum. So last and s last we calculated, and next we put sum. We calculated the sum, that is last and s last, and next we put n comma sum, right? So n comma sum, and next we return sum. So yeah, so this should print result as 5. So let's run this. Yep. So we got the answer as 5. So guys, this is it. So this is how. So this is about memoization, right? So just one more thing. Yeah. So this is basically about memoization. So Yeah. So this is a more efficient approach, right? So like I said, and anything else to add here? Anything else to add? So yeah, guys, no, that's it. So that's it, guys. Thank you for watching.